Galaxies and the universe. Other galaxies were first believed to be nebula or star clusters within the Milky Way, but Edwin Hubble's discovery of Cepheid variable stars in the Great Nebula, the Andromeda constellation, proved existence of galaxies outside the Milky Way. Astronomers have determined the shape of the Milky Way by using radio waves because they penetrate the interstellar gas and dust without being scattered or absorbed. Other galaxies were first believed to be nebula or star clusters within the Milky Way. 6 times 10 to the 11th power times the mass of our Sun is the mass of the Milky Way. Standard model studies claim to provide evidence that there is a great amount of unseen matter called dark matter, composed of dim stellar remnants that have mass. Types of galaxies. Elliptical galaxies. This is an elliptical galaxy. Galaxies that are not flattened into disks do not have spiral arms. Their shapes range from round ellipticals to very elongated ellipticals. A possible elliptical galaxy is Virgo A. Spiral galaxy. This is a spiral galaxy. Galaxies with spiral arms consisting of interstellar matter and young star clusters. A bulge consists of old stellar population. There are normal and barred spirals. A possible example of a spiral galaxy would be the Sombrero Galaxy. The electric universe take on spiral galaxy. One fact that strikes everyone is the spiral shape of some nebulae. It is encountered much too often for us to believe that it is due to chance. It is easy to understand how incomplete any theory of cosmogony is which ignores this. Electric galaxies. For more than 10 years, plasma physicists have had an electrical model of galaxies. It works with real-world physics, able to successfully account for the observed shapes and dynamics of galaxies without recourse to invisible or dark matter and central black holes. Irregular galaxies. These galaxies do not fit the elliptical or spiral classification. They typically have no distinct shape. An example of irregular galaxies would be the Large and Small Magellanic Clouds. Galaxy shapes. A. Be a tightly wound arm and large bright nucleus. C. Loosely wound arms and a small dim nucleus. E7. Very elongated elliptical. EO. A round elliptical. IRR. Irregular galaxy. S. A normal spiral. SB. A barred spiral. And SO. Are flat disks that do not have spiral arms. Halton Arp says the redshift quantization in quasars is a reflection of the density hierarchy in the whole universe. It's an unbounded universe. It is intrinsic to age. Quasars slow down and gain mass over time. Halton says we don't know what's going on out there.
you start in the galaxy nucleus, you get a high density. These are all just rough estimates on my part. In the center of this active nucleus, this mysterious engine where the stuff is created, and we can maybe talk about that informally, that density is very high. So the new particles are in that environment, and they're gaining mass from their environment very rapidly. When they step out of the nucleus, they go into a different, much lower density environment, into the bulbs of the galaxy. And then if they come out in the plane, they go out here. If they come out along the axis, they drop down here. These are enormous drops in density from 5 in the log or something like that. And then finally, when they break out of the local group, they take another stop down, and out of the local supercluster, they take another drop down. This means that these particle masses will be gaining mass very rapidly, and the redshift will be dropping very rapidly on one of these steps, and then it levels off, and then it goes to another step, and it drops. And there are just about 1, 2, 3, 4, 5, 6 drops, and there are 6 major quantization levels. So what we're suggesting is that maybe this redshift quantization that we're seeing in the quasars is a reflection of the density hierarchy in the whole universe. And of course, it's an unbounded universe. We don't know what's going on out there. Okay, one final pretty picture. This is NGC 1097. This is a whole run I had on the 4-meter telescope in Cerro Tololo, and we got these beautiful jets coming out here, and everybody admits that they're extremely mysterious, and nobody knows what they are, but they managed to stay away from investigating them. But because of a friend who does have access to the big telescopes now, we're now starting a project where we're going to observe this object and some of the ones in here. And this is really kind of a discovery astronomy, and that is, this might turn out to be a pure Bremsstrahlung, featureless spectrum, synchrotron emission, plasma, a young galaxy that hadn't even formed atoms yet. Or it might turn out to have a huge redshift, 4 or 5, and then would be a spectacular confirmation. I don't know. The observations are about a month away from being done. We'll have to see. Oh, there's one more thing I want to show. Yeah, it's that crummy drawing that I made. Because this finally I've come to something that really pertains to what this conference is about. And I want to just point out and provoke people and so forth and say that what I think is happening here is that you have a galaxy and an active nucleus, and it throws out one of these low mass plasmas, which is the quasar, in the beginning of the quasar. And there's some sort of magnetic field in the center of this galaxy, or in the center of the nucleus. It's probably tangled. You don't care what the form of that is, because it's stretched out. The magnetic field lines are stretched out this way. Now, this quasar obviously breaks out of this magnetic cocoon, or whatever it is. And at that stage, I would think that it's a plasma, but not a net charge. In other words, you've just vaporized the material, or you're going in the opposite direction, so that the pluses and minus equal, so there's no net charge. However, they're swinging around and emitting all this X-ray and Bremsstrahlung and so forth. As time goes on and they cool, the electrons go into orbit around the protons. That's not a smiling face. That's supposed to be a primeval hydrogen atom. And it's beginning to form atoms and molecules and stars, and this is the progression into a companion, into a new galaxy. And here, I want to emphasize this, because I think this is of interest to this group. There is something known about the magnetic fields in galaxies, and for instance, the Japanese astronomer Sofue and some others have done polarization work in the spiral arms, and they find that the magnetic field lines run out this way and then back this way, in one direction on the outside and the other direction on the inside. And what I think is happening is that these same ejections that are coming out as quasars along the minor axis come out in the disk of the galaxy, and they drag the material out with it, and they form these sort of flux tubes in which there's some material, ionized material of the galaxy, which then is constrained, or maybe even there's pinch activity, and they form these characteristic young stars along the galaxy spiral arms. And so what I'm trying to say is I think there's a unified phenomenon here of ejection from these nuclei, forming quasars, new galaxies out this way, and pulling out material of the old galaxy, forming these new stars and so forth. And that I would suggest this as a sort of a mechanism for understanding galaxies, evolution of galaxies, birth of galaxies, and so forth.
I very clearly remember, though, about 5 years ago when I was reading on the internet and discovered the electric universe theory. And this brought it all back to me. This brought back the joy of science and exploration. It was no longer the science of the advanced mathematics that no one else can understand. Instead, it brought it back to the science that creates this modern world. It's the electromagnetism that we know about in our motors and generators and oscillators, transmitters, receivers. All the things that have created our modern world are incorporated into the electric universe theory.
So I suppose if you really want to know what your whole address is, it would be your address, your state, or your country, and the planet Earth. Which belongs to the solar system. Which belongs to our stellar neighborhood. Which belongs to the Milky Way galaxy. Which belongs to the local group. Of a supercluster named Laniakea, which belongs to the universe. And after that, your guess is as good as mine. But it is fun to speculate. Astronomers say that the Big Bang happened some 13.8 billion years ago. But the Hubble telescope is finding spiral galaxies that are 11 billion light years away, according to their measurements. The Big Bang dictates redshift as an indicator of distance. With a redshift of 2.8, it would be impossible to have formed a spiral galaxy so far away. The further away you look, the further you're looking back. Now, Arp found high redshift objects in front of, attached to, and inside of low redshift objectives. Now, mainstream science, what they did to get out of that was they misrepresented the observations and then disproved the misrepresented data and celebrated. Scientists of the EU, they adopt Arp's observation of intrinsic redshift. Standard model imagines quasars trillions of times larger than our sun, with water around them trillions of times more water than our oceans. Now, galaxies, usually spirals, will go active and build up like a capacitor, release quasars at their poles, or the nucleus, which instead of a hypothesized black hole, there is a plasmoid. Now, Anthony Peratt studied plasma formations for many years, and he discovered that galaxies, rather than being gas and dust, are plasma formations with magnetic fields produced by electric currents. The same electric force that is responsible for the redshift will also give rise to its features. Plasma is confined by magnetic fields. Electricity and plasma form all of the galaxies and structures in the universe. Hey, nice wig. The galaxy has long magnetic field lines that cocoon the quasar that is shot from the galaxy core, the plasmoid at the galaxy core. Eventually it breaks out, which sounds familiar with Earth and Saturn and the Herbig Haro. A lot of cocoons in space. Anyway, it begins to gain atoms. Now they've got all this glorified kerfluffles that have no bearing to reality. Who wants reality, right? Better to close our eyes and imagine gigantic nothingness. As long as we can use words like black hole and quantum, time travel, string theory, inflation, dark this and dark that. What's worse is most people buy it. Just go look at a mainstream cosmology video. The views are in the millions, and it doesn't take long. People are interested, but we're like the backwater. They gotta stumble over us until they find the truth. And like Winston Churchill said about the truth, man, you're lucky to get 100,000. What is wrong with this picture? Meanwhile, over half the population feels lost with no direction. Doctors treat them with chemicals. Everything about man is warped, backwards, upside down. We haven't changed much really at all since the catastrophe. But it's not the people. It is the mainframe is defunct. I've loved science all my life, but I was skeptical of many things, especially in cosmology, my favorite subject. And when you find out about something that was done that was wrong, like the way Halton Arp was treated, how can you ignore that? How can a compassionate human being ignore that? But what is just as bad, if not worse, is how could his discovery or results be ignored? That is contrary to the whole scientific method. I mean, these people are professional scientists, and look how they act. They act like they're sorority brothers. And, this is our side because we have this belief and that's your side. And if you have that belief, then we don't like you and we don't want you to be a part of our little group. And if you do want to be a part of our group, you have to pay attention to the hierarchy. And you can only study this or that, but you cannot go out of these bounds. That's not science. That's high school drama. It has no place in the world of discovery. And that's what gives me the passion to want to try to help it get back on the right track. And I think the biggest thing that bothers me about science, and just about every other area of discovery, we seem to want to make it about the messenger and not the message. Why is that? Why does it matter who makes a discovery? If he makes the discovery and you want to give him his propers for that, then fine. But they make it all about that. I have to say that I take my hat off to people who can put the time in to get a PhD. Like Einstein says, it's the imagination that is a sign of high intelligence, not book knowledge. It's pretty bad when you can pull their guru out on him, on things he says, and then use it against him. It doesn't say a lot for them. But they turn on him like a rabid viper the first time it doesn't agree with him. There's a couple different kinds of smart. There's book smart, There's street smart, and then there's just experience smart, which goes with street smarts.
Sure, there's an old saying, to the victors belong the spoils.
There's another old saying, Senator. Don't piss down my back and tell me it's raining.
Because we're all counting on it, whether we know it or not. I knew something was wrong. Even in the late 90s, early 2000s, there was a dysfunction. I knew that black holes were a mathematical theory, or the way stars and galaxies work. That's just mankind's attempt to put a label on it. Because we love to put labels on things. Is it too hard for them to say we don't know? I don't want to come off as being grandiose. I just want to say that, I care. That's why we're here. We care. And by the looks of things, I have a lot of people that agree with me. We find what's being offered to us unacceptable. Because we're smart enough to know that you can't just throw out some disprovable thing and expect us to embrace it and think it's the truth. To me, science is looking for the truth, looking for empirical evidence and nothing more, and going where the facts lead you. It's the only way you're going to learn. If you invent pink elephants, what does that really do for you? Nothing. It just comes up with a fancy word that people can say to sound smart. Mathematics, to me, can help you gain an aspect of something, like, for example, how to orbit a planet. Yeah, but to put life on a chalkboard with numbers, it's like apples and oranges to me. Just using common sense can get you by. But as it's said, common sense ain't too common.
La 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 la.
Mainstream cosmology says the universe is expanding. But in 1966, Halton Arp proved the redshift was intrinsic to age, and the universe is not expanding. Therefore, there is no reason to expect that the Big Bang ever happened. But instead, they took away his observing time. A veteran member, they just swept his evidence under the rug and tried to get rid of him. How can that not make anyone see what they are all about after doing that? Halton Arp's great work, we got another step closer to the truth of the cosmos, and the electric universe is confirmed more and more every day. In 2013, the Sapphire Project, and they have recreated the sun in the laboratory. Nothing but silence from the mainstream. Really, they just go on acting like a deranged narcissist, pretending not to hear, but shooting it down every chance they get. All the while, looking over their shoulder, shitting their pants in fear. One day, they will live in the garbage bin of yesteryear. In honor of one of my favorite newscasters, good day.